Hey guys, I found something on tray dryer. You want to have a look at it? Let me play the video.
Drying is a separation process whereby water or any other liquids is removed from wet solid in order to form a dry solid. Drying occurs as a result of vaporization of liquid by supplying heat to the wet solid. Drying rate of wet solid in air changes throughout the drying period since the controlling factors are different for each major section of the drying rate curve. However, many wet solids exhibit a period during which the drying rate is essentially constant. The equation used in this experiment is shown as in the slide, whereby Rc is equals to the drying rate during constant rate period. Hv is the total heat transfer coefficient, Tv is the temperature of drying gas, and Ti is the temperature of liquid gas interface. Temperature of dry gas, Tb, is normally measured as dry bulb temperature. Dry bulb temperature is the temperature of surrounding air. At steady state, the temperature of the liquid gas interface, Ti, is equal to the wet bulb temperature. Wet bulb temperature is defined as the lowest temperature that can be reached by evaporating water into the air. Therefore, the drying rate is proportional to the difference between the dry and wet bulb temperature of the air. There are two main objectives for this tray dryer experiment. The first one is to study the effect of air temperature on the drying rate of wet solid in air of fixed air velocity, and second one is to investigate the effect of air velocity on the drying rate of wet solid in air of fixed temperature and humidity. There are many applications of drying process in the industry, such as food industry and pharmaceutical industry. In food industry, drying is important as a method of preservation. Dried foods can be stored for a longer period of time. This is because the microorganisms which cause the food spoilage and decay are unable to grow in the absence of the water. While for the pharmaceutical industry, drying is a very important process as it can protect the component in drugs from oxidation. Other than that, it can also greatly reduce the loss of volatile components in drugs and inhibit the growth of microorganisms and the activity of enzymes in the drugs.
Hey guys, this looks very interesting. Let's conduct an experiment on it.
Sure.
Yeah, let's go. Yeah, let's go. This is our experiment today, which is tray dryer, and this is our equipment. So we will go through this equipment first. This is control panel. So in the control panel, you have the main switch, which is off and on. You have the readings H1, H2, T1, T2, and velocity. You can switch the panel so that you can get different reading for each configuration. And besides that, you got two control, heater control and also fan control. Heater control you can switch to A and B, and fan control 1 or 2. This have a different temperature, and this also have different fan speed. This is to turn on the heater, and this is to turn on the fan. So after this, besides this, you can see the velocity transducer here. This is to measure the velocity of the air flowing inside. While these two are rotronic sensors, which you can calculate. You can sensor for humidity and temperature control for the dry bulb and also the wet bulb. So, and besides that, this is our material. So we can choose either one which is in smooth surface. Like this is not smooth, so we don't choose that. We choose this instead. And this is our sand, which is dry. And then so basically that's all. This is our tray dryer. This is our tray dryer where we put the tray inside this, and this is connected towards this weight balance. So the pressure that exited in here, it will exit at here so that we can get the weight balance.
Okay, now I will conduct for the experiment part A. Firstly, this is the 10mm smooth sand. So first, we need to put inside it to measure it. First, we need to press the 0 button. Put the sand and close it. Take the reading, and then we need to spray twice. Close it back. Then take the reading again. Then we need to set up this controller. First, we need to set it to the A point with the fan speed 1. So this is a adjust controller to adjust between H1, H2, T1, T2 and velocity. And then we need to turn on the fan first before the heater. Okay, turn on. And then start taking the initial reading of H1, H2, T1, T2 and velocity. And then the reading of the temperature and humidity will be taken every 30 seconds until the drying finish, which we can see from the mass of the sand, which will turn into the initial mass. That's all for the experiment part A1. For the part A2, the same procedure will be done, but the difference here is only the heater control. We need to turn into the B control. Okay, that's all for experiment A. Thank you.
Explaining for the procedure for part B. This is dry sand with 10mm thickness and it is smoothened. Now first we need to weigh the dry sand. First of all, we need to tear the button and then put this dry sand inside this. And then we close it and we record the reading. Next, we spray this water to the dry sand, and then we close it back and take the reading. Next, we'll set the heater to B and the fan control to 0.2, and then we can start the experiment. First we on the fan first and then the heater. Simultaneously we take the reading for the H1, H2, T1, T2 and B1. All this value is for the initial one. And for the time interval, we take 1 minute interval because the first one we have too many readings, so that we can shorten the time taken. That's all for experiment part B.
Hi, I will be talking about the errors and precaution part of this experiment. First and foremost, we should wear gloves while handling the device. Other than that, we should avoid ourselves from touching the hot surface at the beginning of the tray dryer. Carry on is the factors that affects our errors in our reading. The first is the inconsistency F movement inside the tray dryer will lead to the fluctuating of the reading, as you can see here. Second is the sensitivity of the reading machine. A slight movement of the device will lead to the vibrating of the suspended tray inside and cause the fluctuations on the reading and the reading machine. Other than that, the F movement inside the device will also cause a vibration too. Third is the faultiness of the sensor. Due to this faultiness, an external device is being used to measure the outlet humidity and temperature. Last but not least is the uneven distribution on the sand and also the water distribution.
I already tabulated all the data, and from this we can't do our graph here because we need moisture content and drying rate. So I have used the formula to get those data, and now as you can see that this is the result part of our experiment. So now I'll be explaining on the results part of our experiment. For both experiments, we will obtain the reading of mass of the sand, H1, H2, T1, T2, and also the velocity of the air. These readings alone is not enough to study the effect of the temperature and also velocity rate of the air. Thus, we need to calculate moisture content and drying rate to get the relation between them. To get the value for the moisture content, the formula is as follows: weight of liquid divided by weight of dry sand, while for the drying rate is difference in moisture content divided by time. After the values for both moisture content and drying rate are obtained, two graphs are plotted for each experiment. The first graph is moisture content against time, while the second graph is plotted with drying rate against moisture content. Now for experiment part B, which is velocity of the air being the manipulated variable, the same graphs are plotted again. The first one is moisture content against time, and the second graph which is drying rate against moisture content.
Based on the result that Harvey shows, right, this is on my discussion, so you can just check it through.
Yeah, sure.
For the discussion, experiment A, the influence of air temperature upon the drying rate of wet sand. Graph of moisture content versus time of different air temperature, we can observe that for both low and high heat air temperature setup, the moisture content is decreasing gradually as time passes by as water is removed out from the sand throughout this experiment. Other than that, we also can conclude that higher heat supply is more efficient for a drying process, as we can observe from the graph below. The moisture content of high heat supply is reaching zero moisture content faster than the low heat supply. This statement comports with the drying theory, in which drying rate is proportional to the air temperature, which in this case is controlled by the heat supply. Based on the graph 2, we can see that the drying rate of higher heater is higher than the lower heater, even though the graph does not reflect to the graph that we should obtain. The real drying rate graph should increase at first and become constant at a point. To be precise, the rate of drying curve should include heating period, constant rate period, and first and second rate falling period. This is due to the error that occurs during the measurement. For experiment part B, the influence of air velocity upon the drying rate of wet sand is being measured. Based on the graph of moisture content versus time, we can observe a gradual decrease of moisture content as time increases, as we can see from the experiment A. This phenomena occurs because of the water is being removed from the wet sand into the flowing air from time to time. Therefore, less water is contained in the sand as time passes by. Other than that, supposedly the air velocity increases, the drying effectiveness increases. But in our experiment, it seems that the trend is showing the other way around. In our experiment, low air velocity reaches zero moisture content earlier than the higher air velocity. This happened due to the error that will be explained in further later. On the graph 4, we can see that the drying rate of higher velocity is higher than the lower velocity, even though the graph does not reflect the graph that we should obtain too. The real rate drying rate graph should increase at first and become constant at the point. And this occurs might be because of the error of the balance and the sensor. For the balance, the weight keep on fluctuating as it was really hard to get the weight of the sand at each time interval. And as for the sensor, we use external sensor instead of the equipment sensor to measure the wet bulb temperature, since the value is completely different.
Kevin, our result discussion, right, is slightly different from theory part of the experiment. So, what do you think is the reason behind this?
You know, our experiment we got a lot of errors as well. So like this in here you can see all the errors that we are facing through.
Oh yeah.
As we conducted the experiment, they might have few errors that occurred which may disrupted the data that is obtained from the tray dryer. This is the reason why the experimental data does not tally with the actual how it's supposed to be. The first error is that the weighing balance may have been affected by air flowing in the tray dryer, causing it to display false weight. The action that we can take is that walls or container must be set up to block air from moving the trays, which disrupts the reading. Secondly, the drying of the wet sand may have not occurred uniformly due to the presence of lumps on the sand surface. So before we start the experiment, we have to make sure to flatten up the sand surface for uniform drying. Thirdly, the water sprayed onto the sand might have not been even. So we have to make sure to spray the water evenly on top of the sand to make sure the water is spread evenly throughout the surface so that the drying can occur efficiently.
Oh yeah, hey guys, we haven't concluded our experiment.
Oh, actually I have done the experiment conclusion.
Wow, okay.
Now let me explain to you about the conclusion. Yeah, see this.
Hello, my name is HAKKIM by KARIM, and I will explain about the conclusion of the experiment. The experiment consists of two parts of experiment. The first is to show the effect of air temperature on drying rate. Meanwhile, for the second part of experiment is to show the effect of air velocity on drying rate. For the first part of the experiment, the effect of air temperature, we can say that the higher the temperature, the higher the drying rate. Thus, we can say also the drying rate is proportional to air temperature. However, for the drying rate versus moisture content graph, there is some error occurs. However, we managed to understand the concept of drying. Next, for the second part is the effect of air velocity on drying rate. The higher the air velocity, the higher the drying rate. Because we also can say that the drying rate is proportional to air velocity. Same like the first part of the experiment, the drying rate versus moisture content graph, there is some error occurs. However, we managed to understand the concept of drying. Thank you.